Heavy loads, moving on a cushion of air. One of the questions we get most often: how does it work? An air bearing is a pneumatic device that forms a lubricating film of air between the load and floor surface, similar to that of a hovercraft or an air hockey table. A flexible, wear-resistant urethane diaphragm is inflated by compressed air, forming a seal with the floor and lifting the structure off its rest pads. Air is then squeezed between the floor and the diaphragm, creating a thin film of air and allowing the load to float. The result is a nearly frictionless platform of air which can move large objects without the dangers of forklifts or overhead cranes. Besides the safety advantages, there are several more reasons that Airfloat air bearings are the practical alternative. First, they're nearly friction-free. When floating on air bearings, a 1,000-pound load can be pushed with just 1 pound of force. Airfloat equipment is omnidirectional. Complex movement patterns combining rotation, sideways, and lengthwise movements are easy, even with heavy, bulky loads. Because an air bearing has no moving parts, maintenance is minimal, and the tray mounting feature allows the air bearing to be removed without lifting the load. Because of the large load lifting area, air bearings won't damage a good floor. The airflow is distributed over a large area, resulting in less point loading.
Hello, my name is Jason Stecker, and I'm the owner of Align Production Systems, and we're here today to talk about our historic brand division, Airfloat and Aircaster technology. In the late 1950s, General Motors engineers were at a trade show, and they were trying to determine how to move cars in and out of the arena without starting the engines. As they were tearing down the booth, they had a large marketing billboard that fell over, and when it hit the ground, it floated across the surface. And this was the original idea for air film technology. Immediately preceding the show, they went back to their laboratories, and with Dave Snowinboss, who ended up being the founder of Airfloat, they developed the first Aircaster at the General Motor Laboratories, and the first patent and Aircaster ever made was called the GM bearing. A few months after leaving General Motors, Dave Snowinboss bought the rights to the GM bearing, and thus Airfloat was founded in Decatur, Illinois as the original Aircaster company. I'm here in the Aircaster manufacturing department with Jason Bublitz. Jason's been making Aircasters for us for how many years?
8 years.
8 years now. This is definitely not a high production run, automated type manufacturing. It's definitely more of a craftsman type manufacturing where we actually take our laser cut backs. We actually have roll forming machines where we manufacture them here. We have press machines, and we actually have a thermoforming machine that we're going to show you next. What you have in front of Jason and I here is a 54x78 racetrack bearing. It's one of the larger air bearings we make. This particular unit is going to get thermoformed in just a minute. Inside the oven, we have a large sheet of urethane heating up right now, and in a few minutes, Jason is going to bring that unit out, and through a vacuum forming process, we're going to form that and allow that material to cool on this buck, which gives it the proper shape to allow for maximum flotation. Now, the key to Aircaster technology is not just in the design of the Plenum, but it has to do with the actual construction. Material choices, design, and construction are all critical to longevity. Spare parts can be a real demanding issue for customers if they're tearing air bearings all the time. It gives us a bad name in the industry. It's not good for our press. It's not good for our customers' performance. And so we are very adamant about our design and our technology for this purpose. Airfloat being the original inventor of it, we had an advantage where the original patents protected our design, which really is what we call a half plenum design, where it's roll formed with the half plenum. The roll forming is critical on this edge because what that allows us to do is as we're going across surfaces, we can actually use our Aircaster as a brake. By simply cutting the air, our unit will not roll under. Now, that doesn't mean that our Aircaster doesn't ever tear. If you get a nail or a staple or a rivet stuck in a crack and you run over it, of course it will slice the face of the bearing. But generally speaking, our air bearings don't tear for our customers, but they're able to move freely, and as they hit disruption of air film, they're able to handle it without ripping the bearing off the face. However, our competitor's Aircaster is a little bit different situation. This is what is called a Taurus style bearing. This is the other common type of air bearing. There is some advantage to it. It's a little bit higher lift. It can actually float in half inflated and then use it as a secondary lift itself to lift something off the ground. However, we don't like the high lift because you also can get a foot underneath it, and it's a safety issue for operators. I'm going to inflate one of these to show you what a Taurus bearing looks like. A little bit different. It's more of what's called an inner tube style or a full round plenum. It's an example of what you see there. Now, the negative with this Taurus style bearing is as it's moving across the floor and you attempt to use it as a brake, because of their construction, it's not roll formed edge. It is actually an adhered to surface. And so what happens is when you try to stop with one of these, it literally rips your air bearing or air caster right off the face of the plate, and then you have to pay to have this replaced. The other disadvantage of the Taurus style bearing is, if you notice, we have two of them here. One of them is a black surface and one of them has a yellow surface on it. We, in our air caster construction, we start with a smooth, solid urethane material that we thermoform. This is a actual nylon reinforced membrane that they actually vulcanize to handle the pressure, and the reason they need the nylon in it is to keep this from blowing apart. The negative with the nylon though is as you inflate this and you're under pressure, the fibers of the nylon press through the face and actually create air film disruption and wear. And as you begin to use this and wear on the face of it, it will tear the air bearing because the nylon threading will wear through. So in an attempt to deal with that, what you'll see is this yellow urethane, like our urethane, but applied in a liquid form over the surface in an attempt to stop that from happening. But even that begins to wear off, the nylon begins to protrude and eventually wear out. And this is why they sell tons of spare parts and why customers are frustrated with this technology. So again, our design is made, it begins with this urethane solid piece construction. It does not have any nylon reinforcing in it. And because of our plenum design, we have the durability and we can use it as a brake without it tearing under and having this type of an effect that occurs when you use it as a brake.